Voltage surges can be a significant problem, leading to damaged electronics and potential fire hazards. Identifying the root cause is crucial for effective resolution. Several factors can contribute to voltage surges. Firstly, lightning strikes can introduce substantial voltage surges into the electrical system. These surges can travel through wiring, affecting various circuits. Secondly, utility equipment malfunctions, such as faulty transformers or power lines, can also generate voltage surges. Problems with the utilities infrastructure can lead to voltage spikes that impact homes connected to the grid. Thirdly, internal faults within the building can create voltage surges. Loose connections, faulty appliances, or damaged wiring can cause voltage spikes that propagate to other circuits. Identifying and addressing these internal faults is critical for resolving the issue. Fourthly, electromagnetic interference, or EMI, from nearby electronic devices can induce voltage surges. Emissions from sources like MRI machines or large motors can affect the electrical system. Fifthly, voltage fluctuations from the utility can cause temporary dips or spikes in voltage during periods of high demand or grid disturbances. Fluctuations can stress electronic components and cause damage over time. To effectively troubleshoot voltage surges, follow these steps. 1. Check the grounding. Ensure the electrical system is properly grounded. Inspect the ground rod connections at the meter base and subpanel. Test the ground wire resistance to verify it is within acceptable limits. A properly grounded system helps dissipate excess voltage, reducing the risk of surges. 2. Inspect wiring and connections. Examine all wiring for damage, loose connections, or signs of overheating. Check for any splices or junction boxes that may have become loose or compromised. Tighten all loose connections and replace any damaged or faulty wiring. Loose or damaged wiring can create resistance and generate voltage spikes. 3. Isolate affected circuits. Temporarily disconnect each affected circuit at the circuit breaker or fuse panel. Turn on the appliances or devices that were previously affected. If the voltage surges persist, it indicates a problem with the main power supply or utility connection. Isolating circuits helps determine the source of the surge. 4. Check appliances and electronics. Inspect all appliances and electronic devices that have been damaged. Look for signs of damage to power cords, plugs, or internal components. Unplug or disconnect any malfunctioning devices and have them tested or repaired. Faulty appliances can cause voltage spikes and affect other devices on the same circuit. 5. Monitor voltage. Install a voltage monitoring device to record incoming voltage levels over time. Check the recordings for any spikes or fluctuations that could indicate a problem. This data can help identify the source of the voltage surges. Monitoring voltage provides valuable insights into the frequency and magnitude of surges. Additional considerations include contacting the utility company to report the ongoing voltage surges. They may have additional information or equipment to assist with troubleshooting. Consider installing surge protectors on all sensitive electronic equipment to mitigate the impact of voltage spikes. Surge protectors help absorb excess voltage, protecting electronic devices from damage. If the problem cannot be resolved by simple troubleshooting, it may require a more thorough investigation by a qualified electrician. An electrician can perform more detailed testing and identify hidden issues. Understanding grounding systems is crucial for electrical safety and preventing voltage surges. A grounding system provides a low impedance path for fault current to return to the source, allowing protective devices like circuit breakers to trip and clear the fault. Grounding helps stabilize voltage and reduces the risk of electric shock. Inspect the grounding electrode system, which typically consists of a ground rod or ground plate buried in the earth. Ensure the connections to the ground rod are tight and free from corrosion. Use a ground resistance tester to measure the resistance of the grounding system. The resistance should be within acceptable limits, typically 25 ohms or less, as specified by electrical codes. If the resistance is too high, it indicates a problem with the grounding system. Improve grounding by driving additional ground rods or using a ground-enhancing compound. Check the grounding conductor that connects the equipment grounding system to the grounding electrode system. Ensure the grounding conductor is properly sized and securely connected. The grounding conductor should be green or bare copper for easy identification. Inspect the bonding jumpers that connect metal enclosures and equipment to the grounding system. Bonding jumpers ensure that all metal parts are at the same potential, reducing the risk of shock. Proper wiring practices are essential for preventing voltage surges and ensuring electrical safety. Use the correct wire size for the circuit to handle the expected load. Refer to the National Electrical Code, or NEC, Table 310.16 for wire ampacity ratings. Avoid overloading circuits, which can cause overheating and voltage drops. Use properly rated circuit breakers or fuses to protect circuits from overcurrent. Circuit breakers and fuses should match the wire ampacity. Inspect wiring for damage such as cuts, abrasions, or exposure to moisture. Replace any damaged wiring immediately. Ensure all wire connections are tight and secure. Loose connections can cause arcing and overheating. Use approved wiring methods and materials for the installation. Follow the NEC guidelines for wiring installations. Avoid using extension cords as permanent wiring solutions. Extension cords are intended for temporary use only. Install dedicated circuits for high-power appliances, such as refrigerators, air conditioners, and electric heaters. Dedicated circuits prevent overloading and voltage drops on other circuits. Surge protection devices, or SPDs, are essential for protecting electronic equipment from voltage surges. SPD divert excess voltage away from sensitive equipment, preventing damage. Install SPD at the main electrical panel to protect the entire house from external surges. Install point-of-use SPD at individual outlets to protect specific electronic devices. Choose SPD with a high surge current rating to handle large surges. Look for SPD that meet UL 1449 safety standards. Consider installing whole house surge protection to protect all circuits in the home. Whole house surge protectors are installed at the main electrical panel. Replace SPD after they have absorbed a significant surge. SPD have a limited lifespan and need to be replaced periodically. Monitor the status indicators on SPD to ensure they are functioning properly. Inspect appliances and electronics for potential sources of voltage surges. Faulty appliances can generate voltage spikes that affect other devices. Check power cords and plugs for damage or loose connections. Unplug or disconnect any malfunctioning appliances immediately. Have appliances repaired by a qualified technician. Use power strips with built-in surge protection for additional protection. Power strips provide multiple outlets and surge protection in a convenient package. Avoid using cheap or poorly made power strips, which may not provide adequate protection. Monitor voltage levels in the electrical system to identify potential problems. Use a multimeter to measure voltage at outlets and electrical panels. Check for voltage drops or spikes that could indicate a problem. Install a voltage monitoring device to record voltage levels over time. Voltage monitoring devices provide valuable data for troubleshooting voltage surges. Contact the utility company if you suspect problems with the incoming power supply. The utility company can check the transformer and power lines for issues. Report any voltage fluctuations or power outages to the utility company. Consider installing a backup generator to provide power during outages. Generators can help prevent damage to electronic equipment during power surges. Have the generator installed by a qualified electrician. Follow all safety precautions when operating a generator. Regular maintenance of the electrical system is essential for preventing voltage surges. Schedule regular inspections of the electrical system by a qualified electrician. Have wiring and connections checked for damage or loose connections. Inspect the grounding system to ensure it is functioning properly. Replace any damaged or faulty components immediately. Keep the electrical panel clean and free from obstructions. Ensure proper ventilation around electrical equipment. Avoid storing flammable materials near electrical equipment. Educate occupants on electrical safety and the dangers of voltage surges. Provide information on how to identify and prevent electrical hazards. Encourage occupants to report any electrical problems immediately. By following these steps, it is possible to effectively troubleshoot voltage surges and protect electronic equipment from damage. A combination of proper grounding, wiring practices, surge protection, and regular maintenance is essential for ensuring electrical safety. If voltage surges persist despite these measures, consult with a qualified electrician for further investigation and repair. Remember that working with electricity can be dangerous. Always take necessary precautions and follow safety guidelines. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Consider consulting with an electrical engineer for complex electrical problems. Electrical engineers have the expertise to design and analyze electrical systems. Stay informed about the latest electrical codes and safety standards. The NEC is updated every 3 years and provides comprehensive guidelines for electrical installations. Continuously improve your knowledge of electrical systems and safety practices. Attend training courses and workshops to enhance your skills. Share your knowledge with others and promote electrical safety in your community. Remember that electrical safety is everyone's responsibility. Take proactive measures to protect yourself and others from electrical hazards. By taking these steps, the risk of voltage surges can be minimized and the safety of the electrical system can be ensured. Proper maintenance and attention to detail are essential for preventing electrical problems and protecting electronic equipment. Contacting a qualified electrician is recommended for any complex or persistent electrical issues. Remember to always prioritize safety and follow established electrical codes and guidelines.